and welcome to this lecture. This lecture we will talk about introduction to technology from a standpoint of a to becoming a tech worker. It could be a software developer, DevOps, data engineer, or you could be a recruiter or a salesperson. It just gives you a perspective of the behind the curtain what is going on when we are talking about technology. So let's begin. So when we talk about technology in today's world, and of course there is a two side of technology. One side is the consumer side. You talk about using Instagram, Facebook, Netflix, Uber. These are all technology driven products. And other side of it is that the what is going behind the curtain. What tools and technology and knowledge that are used to drive those technology, to build those technology. So if you are actually listening to this particular lesson, it means you are already interested in either working in a technology or working with technology resources to understand what it takes. So, in a current technology landscape, there is a lot of confusion going around. The moment you talk about anything, you hear these buzzwords: Kubernetes, cloud, big data, AI, Docker, Python, DevOps. Pretty much everything is nowadays has become so much confusing and tech savvy that for someone as a beginner it becomes extremely difficult for them to understand and where to start and what it is all about. So today we'll demystify this one. So for having a simple example just to understand what technology is, I will take the most common example which pretty much everybody has, what I call iPhone tech stack. It means everybody has a phone nowadays. Even though it's not iPhone, you may have some other kind of smartphone. So we will go inside this smartphone and see what all technologies it uses and how it entails to different technology jobs, and that either you may be dealing with it or you may want to do it. So let's begin. So if I'm talking about technology stack of iPhone, I can broadly divide them as a hardware and then soft or the platform, which is your iOS, and then you have apps, and then you have app store. So in any phone right now, I'm talking about when I'm talking about hardware, I'm talking about these things like phone processor, which actually processes your phone call, video, anything that you're any kind of compute operation you're doing on that. Computer operation by I mean making a phone call, watching a video, sending a text message, or taking a photo. Everything involves compute power, and that means you're using its hardware. So hardware could entail phone processor, sound card, screen, sensors, memory, and storage. And then these hardware that you have, they are nothing for useless if they don't have a software to control the hardware. A software which controls the hardware, it is often called operating system. In this sense, it is iOS. And if you're talking about Android world, you're talking about Android operating system. So, so phone it has a processor, bunch of hardwares, and you need certain kind of special kind of software which maintains or which controls the hardware. Because imagine you have an iPhone which doesn't start, which doesn't work. It means it cannot boot the kernel. It means it is actually useless for end user. So to make a dead hardware working for end user, you need a platform which is called operating system. In case of iPhone, it happened to be iOS. And then once you have the platform, now because the platform by itself, it actually has nothing. Now you need to develop application which will be used on top of this to make it usable. So apps, I will take an example: Facebook, Netflix, Instagram, these are the applications. And then you have App Store. What is App Store? App Store is a repository of application that is stored. It is somewhere in Apple server, and from where you can actually download any app, you can download anything. So if I want to give from an end user perspective, if you see iPhone, you basically doing with these kind of on a daily basis. Let's go to the engineering stack of iPhone. So when I'm talking about hardware, I'm talking about VLSI engineers, FPGA engineers, hardware CPU design engineers. So just to translate it to a what type of people behind the curtain they work in order to make a hardware reality. Similar way, I'm talking about iOS, someone who delivers the iOS, who creates iOS or any operating system. We are talking about kernel developer, C++ developer, network stack developer, device driver developer. These are all different special piece of software which allows you to control the hardware. And then once you have controlled the hardware, you know how to control the hardware, how to turn on the camera, how to switch off the camera in a very simple fashion. Those methods you can expose it to application developers so that they can use it to actually create more different kind of application. So in iOS world, I'm talking about iOS developers, front-end developers, HTML, these kind of developers. So give an example. If I want to give a simple example of a car, if I give you a car which doesn't start, is it any good for you? It is a similar way. If I give you a hardware without an operating system, it is useless for you. Now, okay, the car can start, engine can start, but guess what? In order to start the engine, you have to connect bunch of wires, you have to open the engine and everything, you have to do that. How user friendly it is. If someone wants to drive a car, you want to do something with that. So if you don't want to do that, what you want is that you want a very clean interface like a key. Like you insert the key into a designated location and you switch it on and your car turns on. That is what the job of a platform developer or someone to allow so that anybody can use that car in a very user friendly fashion. Similar way, platform developer, they develop APIs or methods which can be used by application developer to create a next level of application. For example, iOS will give APIs how to use a phone. For example, how to use camera, switch off the camera, switch on the camera, change the focal length of the camera, these things. They will expose these APIs to application developer. And application developer, you will use those APIs to build another application such as Instagram. With that, you can do all kind of fancy things. And where you will store all this application, you will store on a somewhere in cloud, which is your app store. App store is actually a storage in cloud. So when I'm talking about that, I'm talking about like infrastructure engineers, SRE, cloud engineers, server, hardware, DevOps, all these things are over there. So if I right now, if I want to see what type of developer engineers are working behind the curtain of each and every component, you can see the skill set varies dramatically. It is not like one type of people building the whole iPhone. In order to assemble the whole iPhone, you need an army of developer with a completely different skill set and with completely different kind of interfaces that they develop. So let's take again iPhone tech stack. So if I want to put an iPhone tech stack in a very logical fashion, I can say at the bottom it is the hardware. Then you have a special software called iOS which controls the hardware, and then using those iOS APIs you are able to develop application which end user can use it. And all these stores are actually stored in a cloud on an app store. So this is a good example of a cloud as well. So if I take the whole iPhone concept and convert into a computer like a PC based architecture, right? In PC based architecture, I'm talking about here, if I'm talking about hardware, I'm talking about Intel processor. When you buy a laptop, you might see i3, i5, i7, these kind of processor. Memory, how much memory your laptop has, disk and network. Nowadays it is all Wi-Fi routers, Wi-Fi cards. Platform, predominantly you use either Windows, Mac or Linux. These are predominantly dominated platform across the, I will say, generic, I'll say desktop based environment or a server based environment. Application, application could be your MS Office, or could be the application that you are watching right now to watch this video, or it could be a database. So remember, application is something, it could be used by end user, or you can use that application to create another application so that other end user can use it. A very simple example I will give you, Google Docs. In Google Docs, you can use it as a user. You can create documents, write your resume, something like that. And also Google Docs offer some kind of like, you can create, forms. You can create basic forms that you can share with someone else and they will use that form to enter the information. So this is a classic example. You can see how one application can be used as an input to create another application. That is how you create more and more different applications. And where all these applications are stored, if you're storing on the not over the internet, if you want to access them, you're talking about cloud providers. Like very famous cloud providers you can talk about is Amazon, AWS S3. S3 is a product where you can store everything. Azure, GCP, Oracle Cloud. These are some of the names. So you can see how a simple iPhone stack, you can map it to a day-to-day compute devices, and hence you can map it to the server side, and that is how the whole enterprise market is driven. So generic skill set, if I am talking about in case of generic like a PC or a server based architecture, hardware we are talking about VLSI, FPGA engineers, embedded engineers. Then on the platform side, you're talking about Windows developer, kernel, Linux kernel developer, system engineers. On application side, you're looking for Java developers, Oracle developer, PHP, JavaScript, SQL. And on cloud side, you are talking about SRE, DevOps, Kubernetes administrator. So these are the generic skill set you can think of. So let's talk about companies, because this is also very important, because all these technologies have been invented by some or other company, and this is how the whole industry began. So in the hardware, predominantly these companies are dominated like Intel, Samsung, LG, Huawei. They build hardwares. And then you're talking about platform. Platform, pretty much I will say a few names are there, like Microsoft has Windows, Google has Android or their Chrome OS, and Apple has Mac OS. So these are predominantly platform, and using these platforms you can build application. So when you, for example, on application side, when I say Microsoft Word, actually Microsoft Word, maybe the code base may be the same or similar, but the binaries are different for what is for Windows, what is for Mac, what is for Linux. So all these applications are very platform dependent. They have to work on certain things. For example, an app that works on Android, it will not work on iOS. Usually, so this is why you always have a different application, even though they look the same. For example, Facebook. The Facebook app which is running on your iPhone, it is different from the app which is running on Android phone. It happened to have that both have the same functionality because it is done by same developer. So always keep in mind that these applications are all platform dependent. When you are installing Oracle they build different binary for Linux, different binary for Windows, different for PowerPC. Similar way, all other application. And in cloud, I'm talking about major companies is AWS, Google, and Microsoft. So now let's talk about business users, like who uses what. That also gives you some kind of perspective. So when I'm talking about hardware user, who uses this hardware? You will say, oh, I also use Intel hardware. I have a laptop. But actually you are the end user of a software, which is you are using either Windows or you're using a Mac. You are not necessarily taking the microchip from Intel and doing something. What you're doing is that you're using a software which has been pre-built. So who uses these platform? Like companies like AWS, Microsoft, Apple, tech company like IBM. They basically build special software to control that particular hardware. So they are the consumer of those products. They will take from Intel chip, create a motherboard and do something on that. And then who uses those platform? Now you will say, okay, I also use Windows platform. Yes, you use Windows platform as a user, Mac platform as a user. But most cases what people do is they use those platform APIs to build application. For example, your mostly apps, Netflix, Uber, IBM, everybody. What they have, IBM, like Uber is the application, right? Is the application running on top of Android or iOS. It doesn't work for PC because it's not a PC based architecture. But I'm talking about say Microsoft Word, which is a PC based system. So Microsoft Word, what it does, whatever the team of Microsoft in the Word team they have, what they do basically, they take the APIs, either Mac OS API or Windows API, and they build the application. And when I'm talking about enterprise market, which is like your regular, like a bank, insurance company, they are like they use this application to build another application. For example, a bank might use a database from Oracle and maybe app, maybe something I would say Android. application from Google and actually build a banking application which will be used by their end customers. Similar way, they may be using some kind of a, or they will use Oracle database and maybe front end with some JavaScript. They build something. So these are, I will say, app users. And who uses cloud platform? Pretty much the similar, like all enterprise, like government, startup, retail, insurance. Some of the names are here, like major Canadian names. So they all use these kind of application, and they use cloud as well. And when I'm talking about a candidate profile, in the sense that if someone is in the market looking for a job or something, so there is easily demarcation is there. You have to pick your field. It is very rare to have someone has all these skills. It is not like very common. Usually people pick a field and they stay on that field for a very long period of time. So either you are a hardware or you are a platform engineer, you are an application developer, or you are a cloud person. So these are, I would say, some of the job roles are there. So common job roles, if you see in the market, you can think of these: infrastructure management or developer. So these are like DevOps engineer, system admins, SRE, cloud, middleware enterprise, who are actually doing the data wrangling and all these things. So they are like a data warehousing engineer, ETL engineers, Java developers. Backend developer, if you're talking about a mobile application or a web-based application. So backend developers could be microservices, Java developer, Python, Node.js, C Sharp. And front end or mobile developers, you can see JavaScript, React, Angular, or any kind of a C Sharp. They also do, and like Xamarin is a platform to do that. So these are, I would say, common job profile about that. So this introduction to technology was all about giving an understanding of how behind the curtain technology works and how those technologies translate to certain job skills. So when you are actually applying for a job or you are thinking to become one of these, you know which area you will be working on it, which part of the iPhone stack you will be contributing to it. So it gives you some kind of perspective that where you are getting into. And I hope you enjoyed this lecture. Thank you and see you again.